Okay, so now we have an idea what is a welded joint. All the other joints in 2 dimensions are obtained by systematically allowing certain motions. So let's look at one example. This is called a pin joint. A pin joint, let's go up here. You will see what a pin joint does. It allows free rotation. Can you see that? It allows free rotation. So in fact, you can see that here there's a pin joint up here. There's a pin joint up here, and you can see it allows free rotation. So you can see that? Excellent. So now let us see what a pin joint looks like. If it did not allow any motion, we would have Fx, Fy torque, right? But I want to allow rotation. So what happens is I will quietly remove the torque. If I am not able to supply the torque, it will be able to rotate. Now my free body diagram will look like this. Oops. Okay. So a big example of a pin joint is shown here. This is actually what is there in a bridge. Can you see this gigantic pin joint here? It will allow this top platform, it will allow it to rotate and adjust itself. By the way, I want to show you that applying these 2 forces is the same as doing this pin joint. How do I show that? Can you see here? Those are these 2 forces. So now I'm going to only redo this pin joint by applying these 2 forces. So here goes. You can see that, see, it allows only rotation. If you apply only these 2 forces, it will allow only rotation. You see what I mean? If I remove one of these forces, it will do other things, but you got the idea, right? So that's what a pin joint looks like. A pin joint, so a pin equals fixed minus torque. So if you get rid of the torque in the fixed joint, you'll get a pin joint. Okay, very good. Now the next kind of joint we're going to look at is what is called a pin slider. Okay, so let's look at a pin slider. That's a pin slider. So you can see you can do all kinds of things. It can slide and rotate. So just to show you what this thing will look like here, can you see it can slide and rotate? Can you see that sliding and rotating? Right? So there you go. It slides and it rotates. So you got a guide to slide it and you got a pin to rotate it. Okay. So what does that look like? Let's start. No motion. All 3 forces are there. Now I want it to slide in the x direction. So I'm going to remove this force. And I want it to rotate. So I remove the other force. When I remove these 2 things, what I will get is the only force that is there is the y direction force, or the force perpendicular to the thing, because that's the only one that is prevented. So these forces the constraint forces that are left prevent specific motions. Okay, the prevent. So I want you to understand they are not needed for the motion, they are needed to prevent the motion. This is quite different from the kind of forces that you have seen in physics, which always make things move. Here they are preventing things from moving. That's why they are called constraint forces. Okay, this is the big idea. So once you get that, then it's pretty easy. So a pin slider equals fixed joint minus torque minus tangential force. Okay, so that's the basic idea. A pin slider equals fixed joint minus torque minus tangential force. So it left with only normal force. That's how the thing works. Okay, so just to get you an idea of what a pin joint, what a pin slider will look like, look at your common dragging suitcase, you know, the thing that you use to go anywhere. So what the reason is, because you can see it can move this way and it can rotate that way. Can you see that? So for this suitcase, if I were to draw the force at the corner, it will be only this, that's this guy, and then there will be gravity, right, and there will be somebody who is pulling it. This is the motive force, this is motive, and this is constraint. This causes motion going forward, this will make it go down, this one is preventing this corner from falling through. You can see how that works, right? So constraint force, motive force, that's how it works. Okay, now let's look at another example. If you look at wheels, wheels are actually a very tricky thing, but an important idea. In fact, even in that roller, there's a small wheel, right? So if you look at a wheel, if they are not powered, so for example, if you look at a bicycle, the back wheel is powered, right? Front wheel, no power. So at the front wheel, it is like a pin slider. In this particular case, can you see that the front wheel is powered and the back wheel is not powered? So at the back wheel, it will look like a pin slider. Right? It's also called a rocker joint. That is, if you have something that looks like a easy chair, like a rocking chair. You know what I mean? A rocking chair, because it's not powered, it will have only one force that looks exactly like a pin slider. Okay, so remember this, non-drive, non-powered wheels are like a pin slider. These are the rules that you have to remember. Okay, very good. Now we come to a cable connection. This is a very easy thing. I have something and I'm pulling it with a cable, and if you want to see what that will do, here goes. You can see it allows this thing to roll and it allows this thing to swing side by side. Can you see that? So a cable connection allows this thing to go back and forth like this. It allows this thing to swing like this, and it allows this point to move like that. This is another kind of a pin joint, just to make sure you understand. Okay, so this is another kind of a pin joint, and to understand what this does, here is the no motion situation. All forces, all torques are there. Now I want to allow sideways motion, so I'm going to get rid of the torque. Now at this situation, it's able to move sideways, right? But more than that, the force has to be only along the cable. So the final free body diagram, the final portion looks like this. It can swing and rotate, and the force will be there. Okay, so in a cable, cables are special because there is no sideways force. So Fx and Fy are related to each other because the net force has to be along the cable, and this has to be always pulling. It can never push because it can never push on a string. So these things have to be remembered for cables. So finally, we have all our kinds of joints. So built-in joint, you have moment, you have X force, you have Y force. Value and direction are unknown. Okay, the minute you go here, a pin joint, torque is 0, but X force and Y force are there. These two prevent this point from moving. The torque being equal to 0 allows this to go back and forth. That's our pin slider, and as well as our wheel joint. Remember, a non-driven wheel. Now in this particular case, the moment is 0 and the force is along the normal to this thing. The force is like that. The force is along the normal to this thing. Okay. The last one is our cable, and in our cable connection, the force is along the cable. This is the E direction, cable direction, and the force has unknown magnitude but known direction. Unknown magnitude, known direction. Can you see here? It's unknown magnitude and direction. So Fx and Fy are there. Here, unknown magnitude, known direction. In this case, the direction is perpendicular to the slot. In this case, the direction is along the cable. Okay, and you need to memorize these four things. You should know which joint has which kind of force. So the minute you see something like this, you can replace it with that. The minute you see something like this, you can replace it with that. The minute you see something like this or non-powered wheel, you can replace it with that. The minute you see a cable, you can replace it with that. If you remember these four things, you can do quite a few free body diagrams very easily. Okay, so it's well worth memorizing. So please memorize it. Thank you.